As we continue with work, energy, and power, we're going to look at this idea of the relationship between work and energy. And work is the means by which energy is transferred from one object to another. So it's analogous to that you create an impulse and that results in a momentum, right? So you create a ground reaction impulse and your body hurls through the air. So a discus thrower does work and transfers energy to the discus, and the discus flies. The pole vaulter does work on the pole, transfers energy to the pole in the form of strain energy, which then acts on the athlete to hurl them over the bar. So I like to look at this relationship similar to the impulse momentum. And basically you want to increase the kinetic energy, which is kind of the motion energy, so we apply work or force over distance. So there was changes in certain techniques over the years that maximize the work, just like we want to maximize the impulse. And one of these changes in the shot put was, instead of starting at the back and then running forward, right, so you're applying a force over a distance, they moved to the spiral technique, where their back is facing where the direction in which they're throwing it originally, and they do an entire 360 to increase that distance, or that curvilinear distance over which the force is applied to the shot put. And there are other sports that have technique changes that kind of try to maximize this work or impulse, and we can have a discussion on those. So another concept we want to bring up is this, as we talked about before, impulse, momentum, and then impulse. Say, for example, a long jump. You apply an impulse to the ground, your body center of gravity has momentum, mass times velocity, through the air, and then you land again. So you would like to land on a foam pit or in sand to increase that time variable, which will decrease the force. Because remember, you cannot reduce the final landing impulse, but you can change the F and the T variables, or the relationship between them. So for energy and work, you can increase the distance over which the force is applied in that final work scenario to absorb the energy at landing. So in the energy work, it would be you create work, transfer it into energy, kinetic energy, 1/2 mv squared, and then you're landing and you're applying work to the ground, so a force times a distance. So if you can increase that distance over which your body weight is applied to the ground, that force decreases, or you absorb the energy at landing. Same thing when you, quote, give when you're catching a ball. You're increasing that distance over which you're catching the ball to decrease the force, right? It decreases the sting on your hand. A soft landing, right? If you're jumping off a desk, typically you don't do an extended knee landing. You flex your knees, so you're increasing that distance over which the force can act. All right, wind-up and backswings are other strategies that are used to increase the work on a certain ball or whatever it is that you're releasing. And so the backswing in a tennis swing, right? You do a backswing, so you increase that distance over which you swing the racket prior to hitting the ball. For a frisbee, the backswing or the wind-up increases that distance over which you're applying the force before you release that frisbee. Which, if you increase the work, you'll increase the energy, 1/2 mv squared, you'll increase the velocity, and the frisbee or the ball will go farther. So let's just touch on the relationship between potential and kinetic energy. If you throw a ball up, it will come down. So when you're holding the ball in your hand, it has potential energy. And when you apply a force to release the ball, it has its maximum kinetic energy, which then transfers into potential energy. And it has the maximum potential energy when it's at its apex or peak, right? Like in a projectile motion. And that's because it's higher, the height term increased. And then as it changes direction and comes down, Midway, you'll have maximum potential or kinetic energy, and it eventually will land back in your hand and stop and have its minimal potential energy. Okay, one example of this relationship between potential and kinetic energy are roller coasters. And if you think about it, they do not have engines. So how do they make it through the loops? Well, they store potential energy on that initial ascent, right? That stores potential energy to max, and ideally this amount of potential energy that you have stored in that roller coaster should get you through all the loops and turns of your ride. So when you go down, you have lots of kinetic energy, enough kinetic energy to make it through the loop, and then maybe you go to another elevation and store some potential energy, and then you do the rest of the ride. But remember, it's all potential energy being transferred into kinetic energy for a roller coaster without engines.